here, right, now CH3COO minus, right? So now what we are going to do is we are going to consider this CH3COO minus, right? So now CH3COO minus can accept one H plus, and hence it can act as a base. Do you agree with that?
Yeah.
Okay, so this is a base. So I'm going to just take this now, right? So because I have to develop the relationship also, right? So then we can easily establish the relationship, right? So I'm going to dissolve CH3COO minus in water, right? So what can it produce? It can produce CH3COOH and OH minus. Do you agree with that? Yeah, by definition it has released OH minus, so definitely CH3COO minus is a base, right? By definition it has released OH minus, yeah, accepting one hydrogen, so this is definitely a base. So I can write Kc is equal to CH3COOH concentration, OH minus concentration divided by CH3COO minus concentration, H2O, right? Okay.
Okay.
Right. Now Kc itself is a constant. At when the temperature is constant, H2O concentration is also constant, right? So I multiply Kc into H2O concentration and get this expression: CH3COOH OH minus concentration divided by CH3COO minus concentration. Now the multiplication of Kc and the concentration of H2O is called Kb, right? So ionic basic dissociation constant, is equal to CH3COOH minus OH minus concentration, CH3COO minus concentration, right? So this is how we derive the expression for Kb, right? So now can you just mark this down and write the Kb expression for NH4OH?
For N4OH, so you have
for Kb value, how will it be like?
so your Kc value.
No, you don't need to derive. You can just directly write down the Kb value without getting from the constant. I mean the equilibrium constant. So Kb value can be directly written. How can we write?
You have NH4 on the bottom.
Okay. Now when we are supposed to write the Kb value, expression for Kb, now we have to first write down the equation of dissociation of this base, right? So it will become NH4 plus OH minus, right? Now even if you put H2O, how will it become? So it will become NH4 NH3 plus OH minus, right? So if you omit this water, it will be NH4 plus OH minus, right? So I can write, right? So this is just, so we just add water, right? Because all the dissociation will happen in a water medium, right? So if we add water, again, water will dissociate H plus and OH minus, and H plus will attract the vulnerable species, and OH minus attract the vulnerable species. That's all. But if you omit H2O, then it is also okay, right? So if you don't put H2O here, it will be also fine. But for our convenience, we are writing this way because we have to make a relationship between K and KW and Kb, right? So that's why. Now this can be simply written as NH4 plus OH minus, because in the numerator we have to put the dissociated ions, and here we have to put NH4OH. That's all, right? The base concentration will come in the denominator. Okay, right? Can you just write this now? I should have introduced conjugate acid and conjugate bases, but in the content it's not mentioned here. Okay, anyhow.
Okay, got it.
Okay, right. Now we have derived two equations, right? So the first one is this, and the other one is here, right? So what I am going to do is I am going to just multiply these two equations. I'm going to just multiply these two equations. This is first equation and this is the second equation, right? So if I multiply 1 by 2, what will I get? 1 multiplied by 2 will give me Ka into Kb will be equal to CH3COO CH3COO minus into H3O plus divided by CH3COOH, right, into here in the second equation we had CH3COOH OH minus in divided by CH3COO minus, right? So this is what we had, right? So because these are pair of conjugate acid acid and conjugate base, right? Yeah, okay, anyhow, okay, forget about that, right? So now from this I can tell you I can eliminate this and this and this. So what will I left with? I will left with Ka into Kb is equal to H3O plus concentration OH minus concentration, right? So H3O plus concentration into OH minus concentration is nothing but Kw. Did I teach you Kw first?
No.
Huh?
No.
Okay, okay. Now I told you, right? So okay, now
Yeah.
put the heading ion product of water. Ion product of water, right? So ion product of water means, now let's say H2O dissociate as H plus and OH minus, right? Okay, now if I consider 2 H2O, now I am just considering I am mixing H2O with water, right? Water with water. So H2O plus H2O, right? So H2O plus H2O will now become H3O plus, right? So the protonated water, because one H2O, this H2O will dissociate as H plus and OH minus. Now this H plus will combine with H2O and produce H3O plus and OH minus. OH minus, right? Okay, now again I can write Kc is equal to what? Kc is equal to, again I can write this equation like this, right? Okay, right. It is nothing, but we are doing the same process again and again, right? So this chemical equation can be now written as 2H2O. Why? Because we can add the same species. 2H2O becomes H3O plus and OH minus, right? OH minus. Now I can write Kc is equal to H3O plus concentration OH minus concentration divided by H2O concentration square, right? H2O concentration square. Again, what I can tell, when the temperature is constant, again the water's concentration will be constant. So I can multiply this by this Kc. So Kc into H2O plus concentration square will be equal to H3O plus concentration into OH minus concentration. Now again, this multiplication or this expression will be Kw, ionic product of water. So Kw is equal to H3O plus concentration OH minus concentration, right? So this is called ionic product. So from here I can tell H3O plus into OH minus is equal to Kw. From this what can I tell? Kw is equal to Ka into Kb. Now which it means is, if we are given an acid and its conjugate base, their Ka value and Kb value will be the product of Ka and Kb values will give you the water ion product of water. Okay, have you understood this now?
Okay.
Okay, so first write okay, now you can write ion product first, this one first, and then you can write this expression Kb you have written, right?
Yeah.
Okay, so first, okay, now you can just write this down. I have just explained, according to your convenient you can write this down. First you may write ion product of water, then you can write this one also. Otherwise, even after writing this portion, you can write ion product anyhow.